Assalamu alaikum. It's our sixth lecture of advanced application methods and principles of nuclear tracks. In this lecture, we will discuss an overview about the useful features of nuclear track detectors. Then we will overview applications of nuclear detectors. Then we have just a recap of radon. Then we will discuss about the what are the lead contents, basically harmful for teeth and bones. And finally, in this lecture, we will discuss about the alpha decay, and further we will discuss their empirical formula. So let's start our today's lecture. So first of all, we will shortly discuss some useful features of track detectors. Okay, and the useful features is basically the first one is that they are inexpensive. Okay, they are not expensive. They are convenient to use and quiet. Okay, and you can also say there is another useful feature, and that feature is they can be obtained in any size. Okay, their size is not very large, very small size, as compared to very large. Okay, small detectors can be used to measure particle fluxes. Okay, you can also note that. Okay, so that's why this is a good feature, that their sizes are small, not so big, and they are inexpensive basically. Okay, and the next feature is basically they registered track or permanent record. Their tracks are permanently recorded. Okay, not temporary. Okay, they registered their tracks. Okay, and their tracks are permanent record. Okay, of the phenomena under when we investigate the tracks of the particles. Okay, you can also another useful feature of the is that they are insensitive to light. Okay, they are you know that when light falls, some materials are very sensitive. Okay, they lose electrons and they excite electrons, but important thing is that uh, the track detectors are insensitive to the light. Okay, and this is a very good, you can say, a very good feature. Okay, which we are discussing. The next feature is basically they are insensitive to also beta, gamma and x-rays radiations. Very good, very important, because um, the gamma rays and x-rays are highly penetrating. Okay, so they are insensitive to these radiations also. Or you can also they can also used as threshold detectors, like examples I will given to you, like glasses. Okay, and plastic record fission fragment tracks. Okay, but do not record alpha particle tracks. It cannot record alpha particle tracks. Okay, this is a small drawback, but the important thing is they are insensitive to beta, gamma and x-ray radiations. Okay, but they cannot record alpha particle tracks. Who? Track detectors. Okay, and their charge and energy discrimination of these detectors has been found to be better than other nuclear emissions. Okay, so these are basically the useful features of the track detectors. Okay, now we will discuss shortly about the applications of track detectors. Okay, now, what are the applications of these track detectors? Are much of the use of that SSNTD in the nuclear physics research comes from the ability of the method to identify the type of charged particle, okay, that produce the track. So in the case of an extract, two parameters are essentially measured. You know that the track extract Vt and the residual range R, as I told you, okay, previously, at which Vt holds good. Okay, and you know that R is a function of charge, mass and velocity, okay, in particle, while Vt is related to the stopping power. You can say the rate of loss of energy. Okay, rate of stopping power, like radiation loss, dE by dx. Okay, so this is basically the applications of nuclear tracks. Some of other processes of this, like radon. We also know radon is orderless, colorless. Okay, uh, odorless and colorless in nature. It's very harmful for our health to take excessive amount of radon, okay, to inhale this, okay. So this is very disgusting for us, okay, to inhale radon. The next shortcoming we will discuss basically is the lead content, okay, lead content of teeth and bones, we can say that, because you know that many our practical applications, lead is included many of our nowadays in our life, okay. So ss and dt technique basically is being used to measure the lead content, and it's distributed in teeth and bones, and it related if it is possible the age of the person, okay, because this is a new research. People can do research in this, that he can check either how because now you know that there is a research that teeth, many of the teeth are with respect to age becomes weak and weak, because maybe it due to the human is inhaling the lead content more, because that's why, like in paste basically, paste, when you toothbrush, you have a brush and you will paste, you paste add on, and you take your toothbrush. And I think people think there should be some amount of lead content in your paste that affect your teeth with respect to time, okay. And when you are in early ages, your teeth become weak and weak. So this is a new research topic, you can have research on this. People are thinking on this, okay, nowadays. Also bones, there are many things which we are taking as a food, and that was not good for our health, and that also affect our bones, okay. So lead content for teeth and bones are very fatal for us, okay. It basically goes inside, basically you can say they are their life basically half lives basically of this is basically 8.8 days and 138 days respectfully, okay. For you can say for there are three lead isotopes, like okay, pb 206, 207 and 208, okay, on bombardment on helium, or you can say the tritium. So their half life between 8.8 days to 138 days respectfully, okay. So your teeth and bones will start decreasing with their lives, okay. So what happens basically, it goes inside your blood, okay, enters blood supply through your food, and inhalation of car exhaust and industrial population also affects, okay. So these are very fatal and for us. And that's all for the lead contents of the teeth bones. Now basically we will discuss about the alpha decay. And what is basically the alpha decay? You already know, basically it's the helium nuclei, and you already know the formula, chemical formula of the helium is, which is basically He2 4, okay. So another alpha particle is the radon, as I told you, okay, here. So radon decays into the radium 86, radon 88, 226 decays into the radium 86 and 222, okay, with helium. So this is radon decay into radium and helium. So but conservation of energy obey here, like conservation of momentum, like momentum of incoming must be equals to outgoing. So you can see here your radon decays into the an alpha particle, which is okay, alpha, and rn, which is the radium, and this is the recoil, okay. This is the momentum of alpha particle which is producing, it is equal to small mv, and this is the momentum of the recoil nucleus, and recoil nucleus in this scenario is the radium, okay. So capital mv for this case. And if you want to find the velocity, capital v, for the recoil nucleus, so it becomes equals to small mv divided by capital M. Okay. So how you can find the energy of the alpha particle? Basically it's you have to subtract all their masses in AMU. You have the masses are must be given mass of radon. Okay, mass of radon minus the mass of but not this is not radon, this is basically radon, this is radium. Sorry, my mistake. So radium decays into radon and helium. Okay, so you can see radium 88, it decays into radon, which is the new recoil and alpha particle. So mass this is the momentum of alpha particle, small mv, and this is the capital for recoil nucleus, and in this scenario our recoil nucleus is the radon. Okay, radium decays into radon and helium. Okay, so how you can find energy? Simply you have to subtract their masses. So R radium minus mass of radon minus mass of helium particle. So this you can also write mass of parent nucleus minus mass of daughter nucleus minus mass of the alpha particle. So if mass of parent nuclei, let's suppose, is given, which is 23.69, and mass of the daughter particle is also given 16.39, and the mass of the alpha particle is also given, and that is 4.24, then you can easily find the energy in alpha particle by this formula. So put value 2.23.69 minus 16.39 minus 2.42, and you will get your final relation 4.88 mega electron volts. This is how you can find the q alpha value. Okay, means your alpha decay energy, okay, in alpha particle. So you can see radium is decaying into the alpha particle and to the radon, which is the recoil nucleus. Okay, so this is the value of V, but you can see your total energy must be equals to, because it decays into two, radon plus helium. So radon has some kinetic energy and helium must have some kinetic energy. So your total energy must be is the sum of mass is the kinetic energy of radon plus kinetic energy of helium. So whereas the radon is concerned, so it is written as 1 by 2 capital M V square, whereas your helium is concerned 1 by 2 mv square, small mv square. Okay, now what you have to do, only you have to put the value of capital V which you find here. Okay, just put the value of capital V here, and after substituting 1 m cancels with this m, and we have to find the final relation for V square, and we will take V square common from this relation. V square is common, and taking LCM, so it becomes this. Taking V square outside and move all other things other, you will get 2m multiplied by q, 2m multiplied by q divided by m square. Or you can also take one m common, one small m common, capital M plus small m. So this is our final relation of V square. Okay, so you can because we know that the total energy is basically the sum of the alpha particle energy plus the recoil energy. Okay, alpha particle energy plus the recoil energy. So if I find if I have q value is given and E alpha is given, I can easily find recoil. If q is given, recoil is given, I can easily find E alpha. If this two given, I can easily find the total energy. So these are the basically relationship, because the momentum is conserved, the total energy must be equals to sum of both these, sum of alpha particle plus sum of recoil, which is the radon. Now your as you know that your energy of alpha particle, kinetic energy for the case of alpha particle is equals to 1 by 2 mv square. Okay, now what you have to do, you have to put the value of V square here, which you find here. Okay, this v square value in your kinetic energy term of the alpha particle. Okay, this is the kinetic energy term of the alpha particle, 1 by 2 small m v square. Okay, and we have to put the value of v square, which is 2qm divided by m plus m. You will in some cancellation, m cancels with m. Okay, 2 cancels with 2, you will get your final E alpha relation, and that is equals to mq divided by m plus m. Okay, so this is how you can find the E alpha energy. So the mass of the recoil is basically radon, and the mass of radon, that is 2.222, and we also find the q value of radon here. You can we also find the q value of this alpha decay here, 4.88. so you can put here 4.88 mega electron volts divided by small m, which is the mass of the recoil. We know that is radon 222 plus small m, and which we know with the mass of the alpha particle, and we know that the mass of alpha particle is basically 4. After calculating and substituting, you will get your final relationship for E alpha is basically 4.79 mega electron volts. So if E alpha is now given and Q value is already, that 4.88, so you can easily find the recoil energy by this relation. As I told you, this relation. Okay, total energy is equals to sum of recoil energy plus E alpha energy. So if you want to find E recoil energy, so you have to subtract E alpha from Q. So this is the value 4.88 of value of Q minus E alpha 4.79, and you will get your final answer is 0.08. So this is the answer of the energy recoil. Okay, so this is how you can find. So there is another thing, another problem, you can say a short problem, and the problem is energy of alpha particle is, let's suppose, 4.602, means E alpha is 4.602. I have a question to you. Find the Q value. How you can find? There is a relationship between Q and E alpha, and that is equals to this. This is the relation of Q and E alpha. If you want to find Q, so move this with E alpha and divide by m, you will get this. E alpha value we already know, which we find earlier. Okay, you already know the value of E alpha, which is 4.79 plus small m 4 plus capital M 222 divided by capital M 222. So you can easily find the value of the Q value. Okay, so this is how you can easily find Q value of alpha decay, your E alpha value, your E recoil value, your total energy. Okay, so that's all for this. There is another thing, and that is basically the empirical formula. And what is basically the empirical formula? Empirical formula of most of the energetic alpha particles. This empirical formula used for the energetic alpha particles. Okay, you can say, and there is a law for this, is Geiger neutral law, and that law gives a relationship for empirical formula, and that relationship is basically minus ln t a plus b ln of r, whereas t you already know is basically the kinetic energy of alpha particle, whereas a and b are the constants, while your r is basically the range of the alpha particle. So this is the relation of Geiger neutral law for the empirical formula, and empirical formula is basically for the most energetic alpha particle. So for whereas this topic concerned, there is a short problem for you to guide this lecture very best, and that problem, let's suppose an alpha particle has energy of 0.5 mega electron volt, and energy is given, means kinetic energy is given, and the constant value is also given. The value of A is 1.2 and the value of B is 0.5. Calculate range. You have to find range, so you will use the empirical relationship between this. That you have to use this. So first of all, take sum of both these. 1.2 plus 0.5 becomes 1.7, so have to divide this over this. So you can see minus ln of t value, which is given 0.5, divided by a plus b equals to ln of r. can see 1.7 here. So after calculating this minus ln of 0.5 divided by 1.7, you will get 0.407 equals to ln of r. Now to remove this log, you have to take exponential. So r equals to exponential power 0.407 and your final answer is 1.5, and that is your range. Thanks for watching. Allah Hafiz.